All right, here we go. Calculus, Unit 2, Day 13 notes. Objective, estimate the value of the derivative of a function at a point graphically and numerically and use the value of the derivative to find an equation of a tangent line drawn to the graph of a function. Okay, again, we're Unit 2, Day 13 notes. Understanding the derivative from a graphical and numerical approach. Let's look at this picture we have here, and you're going to fill out the chart. I'll fill out the first part for you, and I'm going to give you some time. You can pause the video and try to fill out the rest, then you can go back and look and see how you did. So far, our understanding of the derivative is that it represents the slope of the tangent line drawn to a curve at a point. Complete the table below, estimating the value of f prime of x, which that's the derivative, at the indicated x values by drawing a tangent line and estimating its slope. Okay, so down below they give us a bunch of x values. They want us to estimate what we think the derivative is, and I'm going to say all of them should be integers. Don't try to go to decimals. And then that next column is the function increasing, decreasing, or at a relative maximum or relative minimum. And the last one is come up with the equation of the tangent line at this value of x. And what you're really trying to look for here is what is the point of tangency, and therefore what's the slope of tangency, then use the point slope equation of a line to come up with that equation. All right, so the first one on the chart asks us to estimate what the derivative is going to be when x is -7, and that's really the slope at the point of tangency. So here my point of tangency is, and you're going to do these for all of them. So we look like we're at over 7 down, 1, 2, 3. So -7, -3. And it looks like if this is my uh, tangent line at that point, right here, -7, -3, it looks like I'm going to go up 1, 2, 3, 4 over 1. So that's what I mean by guess. If you have 5, not the end of the world, but we'll say that this is 4. So the derivative of the function at -7 is close enough to 4. Is the function increasing, decreasing, or at a relative max or relative min? Well, the slope is positive, and I can see that it's going from down below up, so as I move left to right, so it's increasing. Okay, so we said it was increasing. Now what we need to find is the equation. So we know what the point of tangency is, and we know what the slope of the tangency is, going back for what we did here on this example. And we said that the slope was roughly 4. So let's come back here and write those down. Again, I'm just going to use the POT for point of tangency and SOT for the slope of the tangent line. And so our point of tangency is -7, -3. Slope of tangency is 4. So using the point slope form, we get y plus 3 equals 4 times x plus 7. And whenever you're asked on a quiz test, or especially if it's on the AP exam, you're asked to come up with the equation of the line, just use point slope form. Don't simplify it. Leave it like that. All right, why don't you pause the video, take a few seconds to try the rest of the chart, and then check to see how you did. Okay, so what do we see here? When the slopes are positive, here f of -6 equals 2, it's increasing. F prime of 3 is 3, it's increasing. When the slope is negative, it's decreasing. And when the slope is 0, we get relative max or relative min, depending on what was happened before it and after it. And we'll summarize this in a second. So again, hopefully you take a second to double check this with your chart. If you haven't filled it in yet, make sure you fill that in. I just want to quickly look all the places where the slope is 0. 0 times that factor is going to be 0, so y minus 2 equals 0. So that ends up being a horizontal line where y equals 2. Hey, we have a relative max, and the slope is 0, and the equation is where the y coordinate, where the point of tangency is. Let's do the next one. We get slope is 0, it's a relative min. 0 times any factor is 0, so we get y equals -4, represent the equation of the tangent line at that point. And the last one is slope is 0 is a relative max. That whole side is going to be 0. Y minus 4 equals 0. Bring the 4 over. We get y equals 4. Okay, and that goes to the graph on the previous page. All right, let's answer some questions on the next chart, and that'll be it for this first video. And hopefully you take a second, based on what you observed in the table on the previous page, what inferences can you make about the value of the derivative f prime of x and the behavior of the graph of the function f of x? So just think about it. If you want to write it down, that's fine, and then we'll check with what we end up with. All right, so what did we learn? First thing, if the derivative at a given point is positive, greater than 0, then the graph of f of x is increasing at that value, x equals a. Obviously, the opposite holds true. If the derivative, f prime of a, is less than 0, so if the derivative is negative, then the graph of the original function f of x is decreasing at x equals a. What else do we know? That the original function f of x has a relative maximum if the derivative of a equals 0, so a horizontal line, and the derivative changes from positive to negative. That tells me it's going to be a maximum. And the last one is the original function has a relative minimum if the original function has a relative minimum if the derivative equals a and the derivative changes from negative to positive. So let's look at those last two. So here it has a relative maximum if the derivatives, so if, and again here if this is my original function, if those are all my original function, all the tangent lines to there are going to be positive. It's going to reach this maximum value. So those are all positive. Then it's going to go to 0, and then it's going to go back down. All the tangents here are going to be negative. It'll be increasing, then it's 0, slope is 0, and then the tangent lines are all decreasing. That's a maximum. Look at the last example. So it's a relative minimum if in the original function all the values of the function have tangents that are negative, get down to that minimum point, and then you begin having tangents that are positive again. That leads to a relative minimum.